Okay, in the last video I showed you how to add a constructor to a class. You can have more than one constructor. So sometimes you might want to create a class using only default values, an object using only default values. Sometimes you might prefer to set, so for our creeper example, for example, you might want to just set the name and use the default number of hearts and the default location, or you might want to set all of those things when it's created. And you can allow your application programmers to create your objects in different ways and set different initial values for different parameters if you add a second, third, fourth constructor to the class, and that's called overloading. So let's take a look at the creeper example here. Right now I just have a single constructor. I can easily add another one, and since I'm not doing anything special with my constructors, I can use Alt-Insert to generate new constructors. So I have one here that just allows you to set the name and the hearts. Maybe I'll add one that lets me set everything. So now I have a second constructor. So it's defined in the same way as the first one, but this one has parameters for all the different values rather than using defaults for these ones here. And maybe I'll add one more as well that just lets you set a name. So let's just set the name. Okay, so that's the minimal one, sets the name, and then what I'll have to do is use default values for everything else. So maybe the default hearts is 4.0, and then the default location is like that. So this is called overloading. Anytime you have methods or constructors with the same name inside the same class, those are called overloaded constructors or overloaded methods. And you can do it as long as the parameter list is different. Okay, and different means a different number or a different type of parameters. So if I try to add public creeper string n double h like that, it's not going to like that. I have a problem with that because it says the creeper, so it doesn't care about the names of the parameters. What it cares about is the types, because you have to think about when I create the object, I'm going to create it and I'm going to pass some values. So if I pass a string and a double, it's not going to know which of these two constructors I intended to be called. If I take this away, then if the user creates calls a constructor that has a string and a double, this is the only one that matches that pattern. These ones don't match. If they call a constructor with just a string, then we get this one, and so on. So over here in creeper main, I've created Chris the creeper. Let's try the other ones. Creeper C equals new creeper. What's another good name? Chris, Carol the creeper. So this one just uses the, let's call this C2. This one just uses the constructor that only allows me to set name. And then let's try the third one. That has Chris, Carol, Candy. I don't know why that one came to me. This one has 5 hearts and a location of 10, 20, 30, like that. Okay, and then we'll print that one out as well, which I can do because I created, let me get rid of these, because I created a toString method. It doesn't like this, why not? Name, hearts, what did I do wrong here? Let's check over here. Oh, because it went hearts name. Why did it do that? Because of the order that I created the instance variables here. But even though I created them in that order, I was thinking about them as sort of name first. So I'm going to just rearrange this constructor that the system created for me. Alt-Shift-L, just rearrange the parameters there. So it's name and then hearts. There you go, like that. Okay, so if I run this, I should see 3 different creepers. The first one had a name of Chris and a hearts of 10, and it had the default location. The next one has the name Carol, but the default hearts and the default location that were set in that constructor. And in the third one here, I overrode that. I set everything. I set all the different kinds of variables. So this is handy. This is just a useful convenience for the programmer. They can use some or all of your default values or none at all. And if I want to have one that's fully just default values, I can go public creeper like this. So now I have, let's use this text here. I copy this and paste it up here. Now I have a creeper with that I can create with all the default values. So back at creeper main, I have a constructor that has no parameters, and now I can print it out. So if I run this, you'll get the fourth one that has all the default values. A name of unnamed, hearts of 4, and so on. So that's the basic idea. Remember that if you define if you don't define any constructors, you automatically get a no argument constructor, one that calls for no parameters, but it does nothing. The minute you add a constructor, you no longer have this default one. So if I, for example, if I go back to here, if I get rid of all of these constructors, it's going to cause errors over here in main. But I want you to think just for a second about which of the lines that I've created over here are going to have errors and which are not. So I commented out all of my constructors here. Go back to creeper main, and you can see all of these are no longer any good because I don't have constructors that match them. But this still works because when I have no constructors of my own defined, it automatically supplies this one here. Now if I go and I put one of them back, let's put back this constructor here. Remember, I'm doing that with control/. That's toggles commenting in and commenting out. Okay, so I've put back one constructor over here. Now this one is okay. That's the one that I put back. These ones still don't exist. And this one, which used to work, is now no longer okay. Because the minute I put in one constructor, Java takes away the one that it had filled in for me automatically. Okay, so, just a few little wrinkles that you need to know about. Now, there's one other thing that I want to show you about these constructors, which is if you notice that we have a lot of duplicated code here. So I'm filling in default values here, and it's the same. These 3 lines reappear over here, and so on. So often what we have is a situation like this where we have one Uber constructor that sets all the values, and then others that set just 1 or 2 values and fill in the rest automatically. You can shorten this code and make it a bit more maintainable by using the this keyword. So we do have a code maintenance issue here, because if we decide that the default number of hearts should now be 7, we have to change that in 2 places. And if we decide that the default Y location is 25, we have to change that in 3 places, and so on. Actually, no, let's edit that out. Yeah. So yeah, we have so what we have here is a bit of a compactness issue. The code isn't as compact as we might like. Also, if there are other things that we're doing in terms of like other code that needs to be run to set up a class, we would have to duplicate it here. So if there's extra code here to do some special stuff to set up the creeper object, we would have to repeat that code here and here and here. So what's nice is to have one constructor that kind of does the main job, does all the work, and have the other constructors just pass off the work to that one. And we can do that with the this method. So for example, up here, if I do this, so I could say this, and then I say, wait, what were my values? Sorry, it should be this, unnamed, 4.0, 100, 100, 100. So now I can get rid of this. What this line does here is it calls the constructor that matches this set of parameters. So instead of me having 5 lines that define all of these things, I just have a single line that calls the big constructor, this one down here. It's going to call this one and pass in the default values to that. I can do the same thing here. I can say this, and I want to pass on the name and the hearts, but the X, Y, and Z values should be 100, 100, 100. So now this one here is only 1 line as well, and it's just passing on what the user called this constructor with a string and a double. I pass those on, and then I also pass in the default values to this one here. Okay, so this is a new use of the this keyword. It's very specific. You can only use it this way. Normally we use the this keyword like this dot to access something. If you use it just on its own, it refers to the constructor, but you can only do it from within another constructor. So I can't, down here, I can't say, you know, this name. I can't do that here down in just a regular method. It says it must be the first statement in the constructor body. It can't be here. The other thing is, the other part of that, first item in the constructor body, I can't call it from here. So here I want to pass on the name, 4.0, 100, 100, 100. I can't do that here either. It's very specific, this statement. It only works if it's the first line of a constructor. And then you can add other code after it, but not before it. Even if I put a SystemOut print line here, it's going to break. It has to be the very first line. Okay, so it's things like this that, you know, that make people kind of shudder in horror. Statements that can only be used in one particular place, exceptions to rules, you know, methods with no return value, stuff like that. That's the sort of thing that drives people towards languages like Python, where everything is much more. If you can do something here, you can do it here. You know, if you can redefine a name over here, you can redefine a name over here. So there are languages that are much more elegant, but they give you a lot of rope, a lot of room, enough rope to hang yourself. So Java keeps you constrained, and there are benefits to that, and there are also costs to it as well. This is just another example of that. So that this keyword can only happen here. The other thing that I should tell you, so let's just run creeper main to make sure that everything still works. So there you go. Everything seems to still be working the way that it was before. If you want to see how this works, you can see I can print out creeper1 here, and then in the big constructor here I could print out creeper2. And then what you'll see is for every time that we create a constructor, there's a creeper2 line, because every constructor is calling this constructor to do the work for it. And this very first one was created using this constructor here. So first we see creeper2 because this calls the other constructor, and then we see the line creeper1. So you can put in those to kind of trace the execution of the program. Now, if we go take a look at the guide here, you can take a look at Circle 5. It contains a number of different constructors, so you can create Circle 5 objects with no parameters, with just a radius, with an x and a y, or with all three, radius, x, and y. So this is an overloaded constructor, and so that means that you can create circles in all of these ways. Okay. Skipping over this to part C, I also just showed you how to use the this keyword. So Circle 6 is a pre-baked example, and this is all in this week's code, where, So I'm using the this keyword again to call this constructor. So all the work is really being done by this constructor, and these other ones are just added as conveniences, and they pass on the work that needs to be done to this one. So this one passes on the radius, and this one passes on the x and y values to this constructor. Now there's one more thing here that I wanted to mention to you. You don't see this a lot in code that people write, but you do see it a lot kind of all over the place inside the Java system. You can also overload methods. So there's a class in here called AddEmUp. What this class does is, if you can see, it has two parameters here, two instance variables, an integer count and a double for the total. It's got an overloaded constructor like this. The job of this thing is, it's like an accumulator. You just add numbers into it, and it keeps track of the total so far and the number of things you've added. So if you add the numbers 1, 2, 3, 4, the total will be 10, which is what you get when you add them all up, and the count will be 4 because we've added 4 numbers to it. So addNums is a method that lets you add a number. So you can pass in a single double, and it will add it to the total and add the count, add +1 to the count. We should have do we have a toString? No, we don't. We have a getAverage and a getTotal method here. These have been folded up by IntelliJ. But we have another addNums method here. It has to have the same return type. and a different set of parameters, and then it's okay to do this, to have two methods with the same name. And this is something you can't do in a lot of languages, but you can do it in Java, and it's very convenient. So what this one lets you do is add, so if you want to add the number 5 10 times, you can call add nums 10 times and pass in the number 5, or you can call add nums with the number 5 and then an integer 10, and it will add the number 5 10 times for you. Okay, so that's how this works. I'll let you guys play with it. The other thing I would point out about this class is that it contains its own main method. Typically what we've been doing is having a main method in a separate class, but you actually don't have to do that. If you want to, you can add to any class you create, you can add a main method. And you see I'm creating an instance of myself here. AtomUp is creating an instance of itself, and then it's doing stuff with it and running it. So this class is runnable. We don't typically do that. It's typically kind of better procedure to put the main method for the project in a separate file. But sometimes you want to do this if you just want to quickly test a single class. Make sure that it's doing what it's supposed to do. You can create a main method inside that class with a bunch of test cases in it to make sure that it works. But anyway, it's here to just show you an example of overloaded methods. So you can overload a class, and you can a constructor, and you can overload a method. And the rules are the same, except methods have return values. And I believe, oh no, this is allowed. So you can actually change the return value as well. But you do have to have different, you don't typically do that. You do have to have different parameter lists. And you do find this all over the place. You might have noticed that SystemOut println can take a string, but it can also take a single integer, it can take a double, and so on. Like here I'm passing it an object, and it's fine with that as well. So I go SystemOut println 67, that's okay. SystemOut println this, and that's okay, even though this is an integer and this is a string. And that is possible because of method overloading. So if we go and take a look in the resources here at official Java API, and we look at the system.out is an object of type print stream, I believe. Print stream, there it is. So this is where the println method is found. And here it is, println. It's defined multiple times for a Boolean, for a character array, for a double, for a float, for an int, for a long, and for an object, and for a string. So multiple implementations, and this is possible because of overloading. And it just gives you the convenience that you can go SystemOut println and put any variable in the brackets, and it will work. So in the behind the scenes, it's calling the correct version of println, and it's doing a conversion to string before it puts it to SystemOut. Okay, so you'll find overloading all over the place inside the Java system. Okay, so that is everything for this video. Let's take a look at the exercises here, which I have to reopen because my thing crashed. Again, there's this dating profile exercise which expands on the dating profile from part 1. We're going to go over those in class. You can give them a try though. One thing you can do though is you can go back to the classes again you were working on last week and add a second constructor. So think about what makes sense for your class. What you might want to have a default constructor that sets default values for everything. You might want to add, have constructors that set just a few of the values. But whatever you do, try and use the this keyword effectively. Okay, you can try C if you want. B is a good one too. So go to AtomUp and try to eliminate code duplication. So have one constructor call the other, which is not doing right now. And also you can have one of the addNums method call the other one as well. So if we go take a look here, here we go to AtomUp. Can you get one of these methods to do the work of the other one so that you can just from one method call the other method? So that's sort of a little puzzle to think about. What would be the best way to do that? Okay, and if you do that, you can make it, if there are ever any changes to implementation that might require you to change both of these methods, now you'll only have to change one because one method is calling the other one. Okay, so those are a couple things to try. That kind of completes the basic object-oriented stuff. Next video, we're going to talk about association, which is a really important concept that's not covered explicitly in the book. It is covered, but it's not kind of ever named and pointed out, at least not in a way that I would like. So we're going to highlight that in the next video, and then we'll do static. Okay, see you in the next video.